Namaste, welcome to Pythagoras Academy. In the last video, when I explained Newton's first law and second law, I said that there is a limitation to the application of Newton's first law and second law. And I also raised a trivia that a person who is moving in a car with some acceleration A is unable to apply Newton's first law or second law on a tree which is on the ground. So let me revise that question again. Consider a tree and a car which is moving with certain acceleration A, then acceleration of the tree with respect to car is acceleration of tree with respect to ground minus acceleration of car with respect to ground. Acceleration of tree with respect to ground is 0 and acceleration of car is AI cap. So acceleration of tree as seen by the car is minus AI cap, which means that a person who is sitting in the car will observe acceleration A in the leftward direction on the tree. According to him, the tree is accelerating, moving with an acceleration A towards left. But consider the forces acting on the tree as observed by the person sitting in the car. It is the weight mg downwards because it has got mass, and normal force applied by the ground because it is on the ground. There are only two forces acting on the tree which are in the vertical direction. In the vertical direction, there is anyways no motion, so net force is 0, it's perfect. But when it comes to horizontal, the person sitting in the car observes an acceleration A, but according to Newton's first law and second law, if there is acceleration, there must be some net external force which is causing this acceleration. But there is no force observed in the leftward direction, but there is acceleration, which is a clear violation of Newton's first law and second law. The reason is that Newton's first law and second law are valid only in inertial frames of reference. But this car is a non-inertial frame of reference. That's why a person sitting in the car is not able to apply Newton's first law and second law on the tree. So Newton's first law and second law are limited only to inertial frames of reference. So let us try to understand the meaning of inertial frame of reference and a non-inertial frame of reference. An inertial frame of reference is that which is at rest or uniform motion with respect to another inertial frame of reference. First, let me talk about a frame of reference. A frame of reference is nothing but a point from where you are performing the analysis on the system. For example, in the previous case, a person sitting in the car is observing the tree. The person sitting in the car is doing analysis on the tree. So the frame of reference is car. The car is accelerating. If there is another person who is standing on the ground and he is trying to apply Newton's laws on the tree, the frame of reference is ground. This is ground frame of reference. So frame of reference is simply the point of observation, the point from where the physical laws are applied on the system. Now there are two types of this frame of reference. Number one, that is inertial frame, as the definition goes. A frame of reference which is at rest or uniform motion with respect to another inertial frame of reference. If a frame of reference is at rest or uniform motion, which means that there is no acceleration, a frame of reference which doesn't have acceleration is known as inertial frame of reference. But as you know very well that anything in physics is relative, there is nothing absolute. The concept of rest or motion is also relative, it is not absolute. So when I use the word rest or uniform motion, it should be defined again with respect to another frame of reference. So it is very difficult to give the definition of inertial frame of reference, because to talk about inertial frame of reference, to define an inertial frame of reference, I need the help of another inertial frame of reference. So the definition goes like this: a frame of reference which is at rest or uniform motion, the one which is moving with uniform velocity, with respect to another frame of reference, another inertial frame of reference, that is known as inertial frame of reference. Similarly, a frame of reference which has acceleration with respect to another inertial frame of reference is known as non-inertial frame of reference. And another name of non-inertial frame of reference is accelerated frame of reference. As the name suggests, that this frame of reference has got some acceleration. So with respect to another inertial frame, of course. So coming back to this example, in this particular case, one, car has acceleration. So this is non-inertial frame of reference. NFR, non-inertial frame of reference or accelerated frame of reference. So Newton's first law and second law are not valid in this non-inertial frame of reference. You are not supposed to apply from the car. Coming to case 2, this is car which is moving with uniform velocity. So if you are applying Newton's laws from this car, this frame of reference is moving with uniform velocity. So it is an inertial frame of reference. So Newton's first law and second law are pretty much valid from this frame of reference, and you can clearly observe that. So acceleration of the car is 0. So acceleration of the tree with respect to car is acceleration of tree minus acceleration of car, which is 0 minus 0, that is 0. There is no acceleration to tree. As observed from the car now, there is mg and n, mg downwards and n upwards. In the vertical direction, there is no motion, so net force is 0. So n and mg are balancing each other, that's perfect. Even in the horizontal direction, there is no force, there is no acceleration, so there is no external force, net external force, and there is no acceleration produced. So Newton's first law and second law are working perfectly because this is inertial frame of reference. Yeah. So the point is Newton's first law and second law cannot be applied universally. There is a limitation. And so if you ask me how should I work or how should I apply Newton's laws from a non-inertial frame of reference, is there any way? And then I would say yes. Though how to work on Newton's laws from a non-inertial frame of reference, there is a technique that we have that is called the concept of pseudo force that I'll discuss in the next video. Thank you so much.